Welcome back. In this video, we will solve our second question from the topic standing or stationary waves. Last video, we solved the first question. I would recommend if you haven't watched that video, go back and solve the first question before solving this one. Because you see, this is the question we had to convert radians into phase difference into path difference. And I explained what does it mean to calculate phase difference and what does it mean to convert phase difference into a path difference. In this video, I want to talk about the word phase itself. What does it mean for 2 points on a standing wave to have same phase, or let's say antiphase? How will their motion be different, let's say, if they are in phase as opposed to if they are in antiphase to each other? Okay, and also how we can look at amplitude of vibration of different points on this standing wave, and what do we mean by antinode and nodes on a standing wave. For all of these things, it's really important to have a visual understanding of standing waves. Okay, how standing waves are generated first of all, and then how can you visualize different points on a standing wave moving. Okay, and for this I have a really good simulation for you, which is this. So first of all, I want you to understand how standing waves are formed. A standing wave is formed when a traveling wave gets reflected and the incident wave and the reflected wave overlap. When this happens, we get a resulting standing wave. So in this simulation, you can see the red wave is the incident wave, the blue one is a reflected wave, and when they overlap, we get a standing wave. Now in this picture, it looks very complicated because we have 3 waves in the same picture. So let me turn off incident and reflected waves. Now we have a standing wave. The second thing I want you to understand is the difference between a standing wave and a traveling wave. A traveling wave actually transports energy from one point to the other. It carries energy from one point to another point. On the other hand, standing wave does not transfer energy from point A to point B. The wave itself, the standing wave itself, will have some energy, but the energy will be kind of trapped in the wave. It will not transport the energy. Our third objective is to understand the definition of nodes and antinodes. So you can see there are some points which are not moving from their mean positions. These points are called nodes. And then there are some points which have the maximum displacement. These are the peaks of the wave. These points are called antinodes. The fourth point that I want you to understand is the amplitude of each point. Notice that the amplitude of a single point remains constant. So they rise and fall to the same height. The height does not change. We say that the amplitude is constant. Also, all the particles reach their respective amplitudes at the same time, which means that all points have the same frequency, right? So this is true for any standing wave. All the points on a standing wave oscillate with the same frequency. The fifth and the last point we will talk about is phase. But before I explain or give you the definition of phase, I want you to remember that the definition of phase is different for a traveling wave compared to its definition for a standing wave. So to repeat, phase has different definition for standing waves and traveling wave. The definition of phase that I will explain in this video will be the definition of phase for a standing wave. For a standing wave, phase is very easy to understand. You can just understand it like this. All the points above the x-axis are in phase to each other. Similarly, all the points below the x-axis are also in phase to each other. But the points that are above the x-axis and the points that are below the axis, they are in antiphase to each other. The reason is that they are moving in opposite directions. Another definition of phase for a standing wave is that if 2 points reach their respective amplitudes at the same time in the same direction, then they are in phase. So you can see all the points above the x-axis reach their respective amplitudes at the same time in the same direction. So they are in phase. Compared to the points that are moving in the opposite direction, they are in antiphase. So I hope you understood all of these 5 points about standing waves. Now we can go back and solve the question. We have to select a statement which is not correct. The first statement, point X and Z are in antiphase with each other. because point X and Z are in different loops, so they are in antiphase. This is a correct statement. We have to remember, we have to select the one that is not correct. Second is point Y and Z have same amplitude of vibration. I already explained that amplitude remains constant for a point. So we can see this is not correct. They have different amplitudes. So the correct answer for this question will be B, but I want to look at other statements also. C is points Y and Z have same frequency of vibration. All the points on a standing wave have same frequency. So you should remember this thing in general. All the points on a standing wave will have the same frequency, because you cannot have a standing wave if you are overlapping two waves having different frequencies, okay? And the last point, point Z is an antinode, which is also true because Z is at maximum displacement from its mean position. So this must be an antinode. This point right here is a node. So the correct option is B.